Hi all, welcome to my YouTube channel Know About Embedded System. So in today's video, we're going to understand how to generate interrupt from external sources and also how to develop the code. So both the things we'll understand in today's video. In the previous video, if you watch my previous video, I have explained you how to generate interrupts from the timer source, but today we will concentrate how to generate interrupt from the external sources. So what do you mean by external source? External source in the sense, in the diagram you can see that this is my microcontroller and EINT, so whatever you are seeing here, these are all external interrupts. That means each external interrupt is assigned to each port pin of microcontroller. So that we will discuss in detail in the next slide. So external interrupts, what do you mean by external interrupts? So external interruptions, already I have told you the definition. Interrupt will be generated from external source, right? So here I have already told you this is my microcontroller and these are all my port pins, and for each port pin one interrupt will be allocated. For example 2.0, so from the 2.0 I can generate interrupt 0. EINT stands for external interrupt 0, then 2.11 external interrupt 1, and so on like that. So external interrupts generated from the external devices or external peripherals. Here you can see an external interrupt. So external interrupt is a signal that will be sent to the microcontroller from the external source, such as push button or the signal change in the sensors. So you can use a push button, nothing but a physical switch where we can generate an interrupt, or you can use sensors or any device where there will be a change in the signal 0 to 1 or 1 to 0. So in that way we can generate external interrupt from the external sources. But whereas in case of our regular interrupts, when you are talking about our peripheral interrupts, in the peripheral interrupts, the interrupts will be generated from internal peripherals like UART, SPI, I2C, and timers and so on. But in case of external interrupt, for each external interrupt, dedicated port pin will be assigned. That is what he is telling here. For external event or for external interrupt, there will be a dedicated port pin will be allocated for each interrupt. That is what I have also showing here. So external interrupt 0, 2.0, something like that. Each interrupt, external interrupt will be assigned with each port pin. Okay, I hope you are clear with the basic definition of external interrupt. Okay, so now external interrupts can be configured in a different way, in the sense there are different modes are there to configure your external interrupt. You can configure external interrupt in a edge triggered mode. There are 4 combinations you can set. External interrupt can be configured in a edge triggered mode. Edge triggered in the sense either you can configure on a rising edge or you can configure on a falling edge. Interrupt can be configured on a rising edge or a falling edge. That's the first point, the edge triggered. So when you say edge triggered, you can see here rising edge and falling edge. So if you want to go for rising edge, there are 2 important registers we have to configure, that is called as ext mode and ext polar. These 2 registers will define the mode of interrupt and whether it's a rising edge or a falling edge. So when you keep ext mode as 1, it is going to configure as edge triggered. Then polar, if you make it 1, it will be rising, and when you make it as 0, it will be a falling edge. So this is a 1 point. And second point, you can also configure as a level trigger. Level triggered in the sense you can make it interrupt as active high or active low. By configuring these 2 registers, ext mode and ext polar, it is possible to generate 4 different combinations of external interrupt: rising edge, falling edge, active high, and active low. So this is the basic information about external interrupt, and let us move back to the coding part here. Coding is very simple. It is very simple. Just only the thing is we have to configure the interrupt combination. So this is your actual code. So this is my inclusion. These are all my macros for port pin selection, port functionality selection, port pin functionality selection, and here I have interrupt configuration function. So in the interrupt configuration here, I'm going to configure my P2.12. So in my board, it is connected to the port pin 2.12, and there is a switch here, and I'm using that port pin as an external interrupt. So the first statement, line number 34, whatever you're saying, that is going to configure P2.12 as an external interrupt, and then line number 35 and 36, line number 35 and 36, whatever you're seeing, the line number 35 talks about a mode. Just now I have spoken about ext mode. Your interrupt will be configured as a edge triggered, and then polar, ext polar, I'm keeping as 1 here, and that is going to configure as rising edge. So these three statements will configure port pin as an external input, and then interrupt as an edge trigger, then a rising edge. So this is my first point. Second point in the interrupt is I have to enable the interrupt and I have to set the priority. So in order to enable the interrupt, we have to use again our functionality NVIC enable IRQ. So this is going to enable your interrupt from the interrupt in the NVIC side. Okay, so I'm going to enable external interrupt 2, then I'm going to set the priority as 1 here. You can give any number, up to 7 different priorities you can assign. So I'm going to assign external interrupt as priority number 1. So this is a function to configure the external interrupt configuration. And this is your handler, IRQ handler. So in this handler, I'm just printing something, one string here, saying that external interrupt 2. Okay, and then I'm clearing the interrupt flag. So line number 46 is clearing the interrupt flag. Okay, so these two are important. One is interrupt configuration and then interrupt generation. So interrupt generation will be done from the hardware side, nothing but there is a switch. So I'm going to use a switch to generate the interrupt. So these two are important. And then coming to the main code here, main code is very simple. I'm calling the function here clock configuration, then UART configuration, then my interrupt configuration, and in while of 1, just I'm going to print something, a small string saying that CPU is normal. Okay, so this much is the coding. Our expectation is whenever there is an interrupt, so it has to go to interrupt service routine and it has to execute this string, or else it has to state in the CPU normal or in while of 1. So I'll flash the code here and let us check the output. I have already compiled it. The flashing is done. So now you can see it says that CPU is normal, because I'm not generating any interrupt. Now I will generate interrupt. Now you can see. So whenever I press the switch, I'm able to generate the interrupt. So whenever I press the switch, I'm able to generate interrupt. Whenever I press the switch, interrupt will be generated, and then the controller will go and execute your ISR routine saying that there is an interrupt from external. So like this, you can generate interrupt. Or else you can see it's a normal operation. So I'm going to generate interrupt. So yeah, so in this way, you can generate interrupt from the external source, and you can develop your embedded coding with the help of external interrupt as well. Okay, so this is configuration, and this is your IRQ handler, and this is your main code. I hope this video is clear. If you feel the video is informative, click on like button and subscribe my YouTube channel, Know About Embedded System.